Hey y'all, welcome back. On tonight's homework, we have just learned what an integral is, specifically an indefinite integral. We haven't yet gotten to definite integrals, but we will get there shortly. So right now, we're just going to continue to practice our anti-differentiation, or you might call it now integration, which is the process of finding those antiderivatives. So let's start with number one. We want to find the integral with respect to x of 8x cubed minus 9x squared plus 4. So I'm just going to approach this extremely similarly, pretty much the exact same way that I did the antiderivatives. So this integral will equal 8x to the fourth. You know what? Let me zoom in here. I'm going to try to squeeze this in. Let's try this again. There we go. Eight x to the fourth times 1/4 minus 9x cubed times 1/3 plus 4x. And then, of course, we're going to add on our c. And then once we simplify that, 8 divided by 4 is 2. So 2x to the fourth minus 9 divided by 3 is 3. 3x cubed plus 4x plus c. So this is the integral. This is the value of the indefinite integral. Number two, when you have a product like this, I'm going to recommend that you multiply or use the distributive property before you go really any further here. We're going to distribute this t squared so that we're now going to calculate the integral with respect to t of t squared plus 3t cubed. And now we can use that anti-power rule to get back to get our integral. So this is going to equal t cubed times 1/3 plus 3t to the fourth times a fourth, and then plus c. After cleaning this up, which there really isn't much to do, we get 1/3 t cubed plus 3/4 t to the fourth plus c. And that is our indefinite integral. Number three. We've got the integral of, we've got 1 over x little guy in here. This is going to cause us to use our natural log integral. But we'll get there when we get there. First, I'm going to rewrite this as x to the 1/2 plus, 1/2 times x to the negative 1/2 plus, I'm actually going to leave 1 over x the way it is. You can write it as x to the negative 1, but keep in mind this is kind of a special case here where we're not going to be able to use the anti-power rule, which is fine. We're just going to have to remember that the integral of 1 over x is the natural log of the absolute value of x. It's something we talked about in the notes. So now I'm going to use the power rule at least on these first two, and I'll get x to the 3/2 times the reciprocal of 3/2, which is 2/3, plus, let's see, I'm going to do my exponent first here, x to the 1/2, and then multiplying 2 by 1/2 is just going to be 1 here, so I'm not even going to bother writing the 1. And then finally, the integral of 1 over x. We talked in class about why the power rule fails on this guy. So instead, we're just going to write this as the natural log of the absolute value of x. And that's just going to be an integral you're going to have to remember. You can derive it. And if you go back to how we actually figured out that was that 1 over x is the derivative natural log of x in the first place, I believe I posted a proof video of that. You can go back and review that or ask me about it later on. I'll kind of go through that with you. Anyway, this is going to be plus c. Okay, number 4. Got some more transcendentals here. Okay, so you're really going to need to start brushing up on your transcendental integrals here. So, for instance, the integral of cosine x is just sine x. So this is going to equal 5 times sine x. And then the integral of sine x is negative cosine x. So this will be minus 4 cosine x. And then the integral of e to the x is just, thankfully, e to the x, right? The derivative of e to the x is itself. So the integral is going to be e to the x plus c. So we have got plus 3 e to the x plus c. Number 5, I'm going to rewrite this quotient. Don't really like how it looks the way it's written here. I don't want to be dealing with a quotient. I'm going to rewrite this as a sum of powers here. So x squared over x to the fourth is going to be x to the negative second power. 2x divided by x to the fourth is going to be 2x to the negative third. And then finally, we've got minus 3x to the negative fourth. We do need to include the dx here. It's going to be a requirement when you find these integrals. Okay, but once you find the integral, that dx, you're not going to write that anymore. You're going to be c. Plus, you're going to have a plus c at the end. So yeah, x to the negative second power, if we use that anti-power rule, or just think about the power rule in reverse, we're going to have x to the negative first, right? And then I'll multiply by the reciprocal of that, which is just negative 1. So get negative 1 x to the negative first power for that first term. For the second one, we're going to increment that power by 1, so that would be negative 2. The reciprocal of negative 2 is negative 1/2, and negative 1/2 times 2 is negative 1 again. For the third term, I've got to increment negative 4, so negative 4 plus 1 is going to be negative 3. And then if I multiply by negative 1/3, I get negative 1/3 times negative 3 is just positive 1. So we kind of lucked out on all those coefficients. And of course, plus c. So I'm going to get rid of all those 1s and just write it as negative x to the negative 1 minus x to the negative 2 plus x to the negative 3 plus c. All right, number 6. We've got secant times tangent minus secant. Now, you might not recognize, this or even this, like what is the integral of either one of those two things? We don't really know that yet, but what we really want to do to make this a little easier is like we did back on number 1. Let me zoom out a little bit so you can actually see this. Oh, is it going to let me? Yeah, I think that's the only way I'm going to be able to fit it all in there, is we're going to use the distributive property and multiply secant y by both of these. So this is going to be the integral of secant y tangent y, and hopefully that's something that you recognize a little bit more. And then minus secant times secant is secant squared. And we have that dy on the end. All right, so yeah, both of these two terms you should recognize from your transcendental derivatives. The integral of secant times tangent is secant. So this is going to equal secant of x. I'm sorry, it's not secant of x, secant of y. And then the integral of secant squared is tangent. So this is going to be minus, stop jumping all over the place here, minus tangent of y, and as always, we include the plus c. All right, moving on. Finding the general solution of the differential equation. This is just a little bit more practice with what we did last time, and a few transcendentals thrown in here and there. So y is going to be, now I'm going to just right above here, rewrite this as x to the 3/2, just as a little reminder that, I'm still going to use power rule on this one. So x to the 5/2 times the reciprocal of 5/2 is 2/5. So I have 2/5 times x to the 5/2 plus, then I've got x squared. The reciprocal of squared is of 2 is 1/2. 3 times a half is 3/2. Now the reciprocal of, I'm sorry, not the reciprocal, the antiderivative of sine is negative cosine. So the antiderivative of negative sine should be positive cosine. So yeah, we're going to add cosine x, and then we're going to add our trusty constant at the end. So we are finding the general solution. We're not looking for a particular one. For number 8, we've got y equals, and just like I did over on the last problem, I'm going to rewrite this as x to the negative 6th, and I'm going to rewrite this other term as x to the 3/4, just so I can look at it a little bit easier. So when I go to integrate this expression, I'm going to increment the exponent. Negative 6 plus 1 is going to be negative 5. And then multiply that term by the reciprocal of that new exponent. So that'd be negative 1/5. So negative 1/5 times x to the negative 5 plus the equation that has 8 as a slope is just 8x, plus some constant, but we'll add on the constant at the very end. And then we've got x to the 3/4. So 3/4 plus 1 is going to be 7/4. And then multiplying by the reciprocal, that's going to be 4/7. And then we have, of course, the plus c at the end. Okay, number 9. We simply have dy dt as 8. Okay, so this is probably the easiest one on here. It's just going to be 8t, and then plus c. Note here that I'm using t instead of x because I'm differentiating, or my derivative is with respect to t, versus you see all the rest of these are dx. So that tells you what the variable should be, in this case t. Okay, moving on to the next section, it says determine f of x. Now, notice how the way both this set of questions is worded is a little bit different than the last one, and it's even different than the last one. But for all these, you're still basically doing the same thing. You're still integrating. You're finding the set of antiderivatives. So let's go ahead and do that. So here, f is 4x squared, and then times a half. 4 times a half is 2. The integral of cosecant squared is negative cotangent. Okay, so if I have negative cotangent, that's just going to be positive cotangent x. And then the integral of e to the x is just e to the x. So plus e to the x, and then, of course, plus c. For number 11, I've got 4 over x. So this is the same thing as 4 times 1 over x. And we know that we're going to have some trouble with that 1 over x, right? We can't use the power rule on that. That's going to be that natural log integral. So yeah, f of x should be 4 times the natural log of the absolute value of x plus c. For number 12, f of x is going to equal 4 times the integral of cosine x, which is sine x, plus 3 times e to the x, plus, can you remember this one? It's been a little while since we did this one, but the integral of 5 to the x is 5 to the x times, let me move this over so I have a little bit more space. So, well, how do I want to write this? Let's start with actually the fraction. 1 over the natural log of 5, okay, times 5 to the x. You could write this as like, maybe I should write this as 5 to the x over natural log of 5. Either way is fine. I'm just kind of running out of space here. And then plus c. All right, number 13. Integrate each of the following. Again, all these problems are basically asking you to do the same thing. You just have to know your integrals decently enough. So let's knock this one out. So this will be x to the 6th, and then 3 divided by 6 is 1/2. So this will be 1/2 x to the 6th. And then minus, let's see, x to the 4th times a 4th plus x squared times 1/2. 7 times a half is 7/2. And then minus x plus c. Number 14, what are we going to do here? I think we got to divide both x and 1 by the square root of x. So I'm actually going to rewrite this integral as x plus 1 over x to the 1/2, just to make it a little bit easier, dx. And then divide each one of these. So x divided by x to the 1/2, we're going to subtract the exponents. So 1 minus 1/2 is 1/2. So that's going to be the integral of x to the 1/2 plus 1 over x to the 1/2. So that'll be x to the negative 1/2. Okay, so now I can just use my power rule. So I've got x to the 3/2 and then times the reciprocal of 3/2, which is 2/3, plus x to the 1/2 times the reciprocal of 1/2, which is 2, and then my plus c. Number 15. I think we saw a problem very similar to this. Was it on the notes? I think maybe the last homework had a problem kind of like this. And well, basically what we're going to do here is we're going to try to rewrite this as a product instead. There's two ways we could approach this. One is to write this as a product. Sine times 1 over cosine would be secant squared. Although we don't really know how to deal with a product either. So what we're going to have to do is use some trigonometric identities to rewrite this. So I'm going to say that this equals the integral of sine x over cosine x times 1 over cosine x. Basically just separating out the cosines, and you can double check and make sure that this is true. Sine times 1 is sine, cosine times cosine is cosine squared, so this works. And then sine over cosine is, well, that really is just the definition of tangent. And then 1 over cosine is, since cosine is the reciprocal of secant, that's just secant. So here we have tangent of x times secant of x dx, and we know that integral, or at least you will very shortly. The more you deal with these, the better you're going to know them, but at some point you are just going to have to know all these integrals. So secant times tangent, the integral of that is secant. Okay, number 16. Still don't know how to deal with products yet, but we can multiply up front and then handle what we have left. So I'm going to just use my distributive property here and get 4x squared minus x minus 4x is going to be minus 5x, and then plus 1. All that times dx. So when I integrate, I'm going to increment the exponent and then multiply by 1/3. 4 times 1/3 is 4/3. On the next term, I've got x squared, and then 5 times 1/2 is 5/2. And then the integral of 1 is x. And then we have a plus c. Number 17, I'll handle this similarly. I'm going to multiply them together up front. So 3 plus a half. Well, 3 is 6 halves. So 6 halves plus 1 half is 7 halves. Incrementing that by 1 will be 9 halves, and then I need to multiply that by the reciprocal 2/9. And this is just a one-term deal here, so I'm going to leave it just like that. And then it looks like this last one's going to be sort of an easier one. The integral of 4, well, we know that's just going to be 4x plus c. Okay, number 19 says if the second derivative of f is 6x plus 12x squared, determine f. All right, so here we're going to have to kind of work backwards to find f. Now, as we do that, we're going to end up with two different constants. So we're going to have to give that second constant a different name. But let's cross that bridge when we get there. So we got f double prime here. So let's write f prime. F prime, we know how to find this at this point, is going to be x squared times the reciprocal of 2 is 1/2. 6 times a half is 3. So we get 3x squared plus, let's see, 12 divided by 3 is 4. So 4x cubed. And then plus c. So that is the equation for the first derivative. But what this is actually asking for f. So we're going to have to integrate again. We're going to treat c like it's a constant. Well, it is. And so when we integrate, just pretend that's like 5 or a number like that, and integrate it that way. So f will be have x cubed, and then 3 times 1/3 is just 1. So that's just going to be x cubed. And then x to the 4th, 4 times a 4th is 1, so that works out pretty nicely. And then the integral of c would be c times x. And then we do have to add on another constant that doesn't necessarily have to be the same as the constant we got from the first derivative. So I'm just going to call it d, okay, as like another constant. So yeah, there are going to be infinitely many different solutions here, right? And you've got, infinitely many C's and infinitely many D's. So you've got quite a good number of antiderivatives of 6x plus 12x squared. Or not antiderivatives, but the antiderivative of the antiderivative of 6x plus 12x squared. Number 20 says, use the differential equation to answer the questions that follow. First, find the general solution to the differential equation. So that means we are just going to find y. So y, oh, come on. There we go. So y is going to be x cubed times 1/3 minus x plus c. There's really nothing else to talk about there. We've done a bunch of these at this point. B says, if you know the solution contains the point -1, 3, determine the particular solution to the differential equation. And we know how to handle that at this point now, too. We're going to substitute in -1 into x. We're going to substitute in 3 into y, solve for c, and then just rewrite the equation with the c value that we get. So 3 equals 1/3 times -1 cubed minus -1 plus c. So -1 cubed is going to be -1. So we have -1/3 plus 1 plus c. So 3 minus 1. Hang on, am I missing something here? 3 minus 1. Yeah, I guess it's just going to be what it is. So 3 minus 1 is going to be 2. 2 plus 1/3. 6/3 plus is going to be 7/3. So that's my c. But the actual particular solution is going to be y equals 1/3 x cubed minus x plus the c value we just found, 7/3. All right, and that brings us to our very last problem for tonight, number 21. It's a multi-step problem, of course, but that's all right. We can do this. Use the given information to solve the differential equation. Solving means to find the function f that satisfies given information. So we're going to do basically like what we did back here on 20, but for each one of these. So for A, we're going to find the general solution first, then plug in the point that's given to find f. So f is going to be, let's see, x squared, 10 divided by 2 is 5, so 5x squared minus, we got x to the fourth, and then 12 divided by 4 is 3, so minus 3x to the fourth, plus c. Now, if I know that f of 3 is 2, I can say that 2 equals 5 times 3 squared minus 3 times 3 to the fourth plus c, so that I can find my c. 2 is, let's see, 9 times 5. 9 times 5 is going to be 45 minus 3 to the, oh God, is this for real? The c value is just like out of control here. Let's see what we got here. 3 times 3 is 9. 9 squared is 81. Do a little quick math over here. 81 times 3 is going to be 243. Okay, well, yeah, so 2 plus 243 is going to be 245 minus 45. So actually the c value just comes out to be 200. Okay, so now we can solve. We got the f of x, we got the c. It's going to be 5x squared minus 3x to the fourth plus 200. Yeah, we're going to do b pretty much the same way here, although you do need to know your trigonometric integrals. So f is going to be the antiderivative of cosine x, which is sine x. So it's going to equal sine x plus c. And then to find c, I'm going to use the given information. So 4, I'll just, come on. I don't know why I have so much trouble with this thing staying still. 4 equals sine of pi plus c. Now sine of pi, don't forget, pi is right here. Coordinate on the unit circle, -1, 0. Sine's going to be 0. So that means c is 4. And so f of x is going to be sine of x plus 4. Now for c and d, we're going to have to start with the second derivative and work our way to the first derivative. But we can do that. So let me zoom in here on c. If the second derivative of f is sine of x, we'll first integrate that, find that antiderivative of sine x, which is negative cosine x. So f prime will be negative cosine x plus c. And we need to find that c so we know what the first derivative is. Well, f of 0 is 1, so 1 equals negative cosine of 0 plus c. Now cosine of 0 is 1, so we've got 1 equals -1 plus c. So c is going to be 2 here, which means f prime is negative cosine x plus 2. Now if I'm looking for f, I need to integrate what I have there. The integral of cosine is just regular old sine, so this is going to be negative sine x plus the integral of 2 is 2x, and then I have another plus c. We might call this d, just so that we already kind of used up c as a name. If you call this c, it's not that big a deal, but just want to make it clear that these are different constants. Now we do need to find that constant, and we're going to use information about f of x to get it. So 6 equals negative sine of 0 plus 2 times 0 plus d. Sine of 0 is 0, so we get 6 equals 0 plus 0 plus d, so 6 is d. And then so now we can write our function f. It's negative sine x plus 2x plus 6. And that brings us to our very last problem here, which we will work out extremely similarly to that last one. Okay, we'll basically do this, take the same steps. Okay, so first let's find the first derivative, f prime, which will be, if I increment this, it's going to be x to the negative 1/2, right? And then multiply that by the reciprocal of negative 1/2, which would be negative 2, plus c. I need to find that c value. So I know that f prime of 4 is 2. So 2 is negative 2 times 4 to the negative 1/2 plus c. Now, raising something to the negative 1/2 is the same thing as saying 1 divided by the square root of 4. The square root of 4 is 2. So this is really just 1/2. So we've got 2 equals negative 2 times 1/2 plus c. So that's going to be 2 equals negative 1 plus c. And so c is 3. Okay, I'm going to actually move this over and start a new column here because I don't want to run out of space. So yeah, so f prime is going to be negative 2x to the negative 1/2 plus 3. Now we're going to use that to find f. F, if I increment negative 1/2, negative 1/2 plus 1 is just 1/2. And the reciprocal of 1/2 is 2. So 2 times negative 2 is going to be negative 4, x to the 1/2 plus 3x plus some other constant, which I'll call d. Now we know f of 0 is 3. So 3 equals negative 4 times 0 to the 1/2 plus 3 times 0 plus d. So that's just going to mostly just all zero out, right? Let's see, 0 plus 0 plus, so yeah, d is 3. So we can say that f of x is negative 4 x to the 1/2, or the square root of x, plus 3x plus 3. And that is going to wrap it up for tonight's homework. And, as always, please reach out if you have any questions. But y'all have a great night. I'll see you next time.